Okay. For the online students, can you all hear me? Is my voice clear? Okay. Okay. So we are doing online and offline class at the same time. So yeah, whenever you feel you need to take like online, you can do so. But I think because your TA need to be physical, right? Yeah. Okay. Okay. That's okay. Because the other TA for this class, he has the same method with me because we're still waiting some students from uh, overseas students. Yeah. Uh, yeah. This is our physical class, first physical class together. So hopefully we can be more because sometimes when I teach uh, online, sometimes I don't really know what you are guys doing. So yeah, uh, for the physical class, I know what you're doing, and uh, like I said, I think I've said previous class that uh, I don't mind if you are taking some snacks or lunch in class, as long as it doesn't make noise. Okay, as long as it's okay. Okay, but if it make noise, I will get distracted. Okay, okay, and then when you feel you need to rest for a while, you can do that also, but don't rest for the whole class. Okay, it's 5-10 minutes. That's okay. Okay, I hope you guys already scan the QR code. Yeah, I believe this is what you guys are thinking when I pass this course. All right. Okay. Maybe we start with some evaluations for our feedback last week. Okay. We have the question is, I think you have the parabola. So this is the parabola, right? Parabola. The parabola. You have the x squared plus bx, and it is mentioned that uh, the tangent line at 1, 1 is this equation, y equal 3x minus 2. Okay, and it's asking about the a and b value, right? Okay, so first thing, every time you read tangent line for any functions, it means that the tangent means you need to find the first derivative to calculate the slope, okay, okay, the m. Okay, so we just derive the uh, the function y here, derive. So the first derivative is just 2ax plus b, and then we know that the point that we are looking at is x equal 1, right? So we put x equal 1, we get 2a plus b, and we know that from the questions that the slope, the tangent line for the slope is 3, right? So that means we have this equation, 2a plus b is 3. Okay, that's our first equation. We need the second equation, which is we just plug in the y. So let's say we have right. That means here, and then we can calculate ab with the two equations. Okay, we got the a is 2 and b is -1. Okay, so that is the first option here. Okay, okay, okay. Next question is about the uh, horizontal tangent. Horizontal tangent, and the function is e. Uh, attendance code. After this, okay. Wait for this question. So first, horizontal tangent means that the first derivative or the slope is 0, right? And then we need to find which x value that has, if we are writing this, f prime, we differentiate, derive, okay? And it should be equal 0 because it's horizontal tangent. Horizontal tangent. And you get that this is actually e to the x is equal to, or if you want to take the x, it's equal to ln2. If you will a little bit maybe um, need some review, you need to review the logarithm functions. Okay, log logarithm. This basically you are making log, and then x become here, and this is actually ln, and that's how you get the x equal ln2. Okay. Yeah, most of you are doing good job. This is should be x. Okay. So yeah, uh, yeah, keep practicing your calculus to increase your skills. But I don't really pressure you to how to say that. There are difference between uh, hard work and uh, working smart. A few difference. If you're doing like just hard work only without knowing where to go and your body limit, uh, sometimes you will feel exhausted, but you don't really achieve your goals. Okay, so what I mean is keep practicing in a smart way. Okay, that means you need to know yourself more, like what you want to do, what's your purpose, what's your goal, maybe why you are doing this whole thing in the university, taking some courses. If you know what you do, I think you can get like manage your life better. Okay. Okay. Maybe for some students who just come in, you can check the attendance here. Okay. And then we can continue afterwards. Okay. Oh, by the way, have you take vaccination? Yes. Yeah. Actually, next week, next Tuesday, I will get my vaccination. So probably Tuesday class will be online. Okay, will be online because I think the time is not enough for me to go to the clinic. Okay, let's continue. Let's continue. I think last time we are doing the chain rule, right? The chain rule. So this is the official terms. Okay. Okay. So the first thing is we need to know all the functions in the composite. We have the composite here. The composite f is, let's say we have this. Okay. So every function in the composite is differentiable. That's the first thing you need to know and you need to keep in mind. So whenever we have this big function f, okay, we can derive and making this as our conclusions. Okay? You can also write, it is the another notation. We call the Leibniz notations. We can write if, okay, y is f of u and g is function of x, we can combine all together, becomes dy dx equal dy du multiply with du dx. Okay. And I think if you are going to learn further about math or advanced math, this chain rule will be really helpful. Eventually, when you reach the some, maybe you learn about some chemical process that requires some chain rule, or maybe some mechanical formula, and then you need to differentiate. The logic in the chain rule will be helpful for you. Okay, let's see how we can. Actually, I want to prove, set in proof the chain rule, how this is true for all chain rule. Okay, let me write here. Uh, Let me write this is proof. So first, if y is f and then gx, and then I want to prove that this is true. Let me write first this statement. Okay. In the next part, if y is f of x, so this is first statement proving this. The second statement is where we are actually start. Okay. So if this is f of x, uh, maybe here, x change from, let's say, some a uh, to a plus some delta x. Okay, this is, remember, when we are dealing with the limit, we have some small increase. Okay, and then we have the delta y, which is the difference between the height. Okay, the height of function of a and functions of a plus delta x. So when you increase the delta, there will be an increase of the delta y. Okay. So in a limit rule, if we limit the delta x closer to 0, we know that this, and when we divide with delta x, okay, it's similar with what we have done in limit definition. This will be delta y, delta x, and it should be f prime a. Okay, this is the intro. Next, the proving parts. We need to have some terms. Okay, well, some terms that are really small, that can actually be something in between of our limit. So because this is limit and this is actually our first derivative, actually in definition this is true. But when we are dealing with limit, we're dealing with a small value that is really small, that if we compute, we ignore that, right? We remove that small value and we just, okay, this is the same as that. So actually there is a small difference. Okay, so we can write that small difference. Oh wait, there's okay. So we can use the let's say the epsilon. This will be difference between delta y over delta x and f prime. Okay. And we limit this epsilon as delta x closer to 0, delta y over delta x minus f prime. Okay. In a sense, if you are thinking that the delta is f, also f prime of a, it should be 0, right? So that's why we are going to have the limit. Okay. So let me write maybe to make you feel this is okay. This should be this. Okay. But we have this epsilon. Okay. Now to prove the whole thing, let's say this is equation 1. Let me move here. Let make 1 is, we know the delta y is equal f prime a delta x plus, if we uh, simplify, change a little bit, this will become functions. And as delta x approach 0, epsilon also approach 0. Okay. And then if the epsilon defines as 0 when delta x 0, this means it is continuous functions of delta x, meaning there is no other difference, right? It's continuous. And then suppose uh, suppose we have another u, it's g of x, and we have also y. This is f of u, and let u differentiable at a, at some number a, okay, and let y differentiable at b. So b is g of a. And then if delta x, delta y, and delta u, they are all small, let's say increment, all small increases, small increment of x, y, and u, then we can compute that into, okay, so this is the first. The second is delta u is equal, okay, let me, okay, I think we can put it, I think here should be okay. So that I will write all in the same paper. So delta u will be g prime of a delta x plus we have another epsilon on U. Maybe we write E1, okay? And then we can factorize delta x and make it T prime plus E1 delta x, okay? And we can also mention that as delta x approaches 0, the epsilon 1 also closer to 0. And then the third equation we have is delta y. This is f prime b delta u plus epsilon 2 delta x. Okay. Oh, wait, not delta y. It should be u. Okay. And same goes by here. And this will be delta u. Okay. And we can also write down that as delta u getting closer to 0, our epsilon also getting 0. And then we can combine these two equations here. So combine 2 and 3. So we can write, okay, we can write, because you see that this delta u here, we can exchange to this, okay? So we combine those together. Let me write with black. Delta y is f prime b plus epsilon 2 d prime a plus epsilon 1. And then delta x. So delta y over delta x. Okay. And then finally, we can write the definition dy dx is equal when limit as delta x getting 0, which means the epsilon is going to be 0. We can fully say that this becomes f prime. Let me just write, let me just write the epsilon first. All right, and then maybe right here as delta x going 0, then epsilon 1 and 2 also going to be 0. Then we get this will be f prime b g prime a, or because b is actually g, function g, so we can write f prime g of a g prime a. So it proves that by imagining the difference on the delta, that is epsilon, we can actually proving that what the chain rules say. Okay, so we can make it into the general chain rule. Okay, if you want to look in more details. Okay. I think the important part for the chain rule, only the chain rule, is this part. The first part is to introduce you to the symbols, the terms, and then put inside this chain rule. Okay. So like this one here, the first one here is to make you familiar first with some term symbols. Okay. Like the epsilon here. What's the epsilon? It's this the small difference between this delta and the actual f prime. Okay. And actually, if you are thinking just okay, looking at the equations, we look at the delta and f prime, is actually they will cancel each other. But here we are going to have our real epsilon, okay? And then put inside the chain rule here. So we have 2 epsilon, but then again, because of limit, okay? So this is why a limit is important. So because of limit, we can say that, okay, when the delta x is getting closer to 0, our epsilon also getting closer to 0. Okay? So we can also eliminate the epsilon, and then we can prove that, okay, the chain rule is correct. Okay? This may seem really complex, but actually it is based on what you learn in limit and how to prove how the derivatives work. Okay? The difference is you need to let the I think the important thing is here. The important thing is here. You need to know what's the connection between these two, and then you put into the delta equations, and you put them all together. Okay. Okay, but if you feel like this is too really complex, or maybe um, you need some time to deal with it, that's okay. Even some students, they pass the course, they still don't understand this. That's okay. That's okay. The important thing is, you know that if you have the chain rule here, you know that the idea of chain rule came from the derivative came from limit, and the limit is came from how you deal with something close to another number. Okay? As long as you get that point, whenever you are, because maybe sometimes you forget, sometimes you need to review, that's okay, that's okay, that's okay. The whole thing in mathematics or calculus is not to memorize all these steps, and not like that. As long as you know the how to deal with it, how to take the steps, that's fine, that's fine. Okay. And I don't want you to memorize this. Okay, do not memorize this. Okay. Okay. Let's see. Okay, let me give you some examples. I think I haven't given you any examples, and maybe to make you familiarize. I think you have chain rule on high school, or no? Half, right? At least half, right? But not really a long or complex one, right? Okay, let me give you this to familiarize yourself with the chain rule. So, okay, before that, let me give you with the uh, y is sine x squared. Find the first derivative. Okay, you can try first and see if you get the idea correct or no. Yeah. Okay. Pam, Chuan, you say to yes. Okay, correct. Okay, some students already answer in the chat box. Okay. All right. Okay. Need to connect this to. Okay. Okay. Now the idea, because at the beginning we already defined that this is actually a chain rule is a composite, let's say a function of f or g, but you can also make this any functions you like, right? As long as it is composite. Okay? But if you don't like how the function is written like this, maybe we can start with the let's just say you have inside functions, right? or inside functions, and you have another functions that is outside functions. Okay. Okay. Remember that when you have the chain rule, it's began with you can put any variable you want. Let's a, and this should be a dx, and we are going to have which functions is this, right? That need to be put here. So first, you look at the outside function. Probably the outside function is just any variable, let's say x. Maybe this is the functions, the outside function. And the inside function is, of course, sine x, right? So you deal with the y prime is you deal with the outside functions, which is x squared. It is 2x, but x is actually sine x, so you write just as it is, and then you multiply with the sine x derived, or maybe write d dx sine x. So step by step, this is become this. Okay. Okay. It's important if you are just remembering that this maybe let's say you have this, right? And then you say that okay, I can derive this. Derive the first one and then find the inside one, right? It's okay, it's still good. But then if you have more than two functions, maybe three, four, five, sometimes if you just use this logic, maybe it's not really helpful. So probably if you have like f, g, and then h, and then maybe k, and then x, you need to deal one by one. Like for example, deal with the outside functions. So you write f prime, g, k, x, right? And you need to deal with the inside function of g, and then this is like a nested problem. So we need to have d dx. We have another g prime something here, and then d dx, and then this will be start from start from h, sorry, h something something something, and you have another one h prime blah 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 until we get k prime. It might happen, but if you stick to the how the problem can be solved, looking at which one is inside function, outside functions, you can solve as many questions as possible with the chain rule. Okay, if you already know how to deal with it. Okay. Okay, let's start another example. Another example. If we have y is equal 5 minus 6x with 5. I think this should be easy. So first, looking at the outside function, which is something with the power of 5, right? So we can differentiate that, making, let's just say we're going one by one. So 5, and 5 minus 6x is 6x, and then with a 4, okay? And you need to multiply with inside functions like that. But then this is just 6x, and we can multiply with the 5 here. So it will be negative 30. 5 minus 6x to the power of 4. So again, like for example, this one, we can have as many as possible for the chain rule. Okay, so why is called the chain rule? Because if you look here, let me maybe dy, du, du, let's say dv, and then dv, dy, and then dw, and dx. You see that it looks like chaining all parts together. So that's why it's called chain rule. So it's connected to all functions here, right? So the function here is all connected between functions, because you know that it's because of the composite. So because it's connected, when you derive, you need to also connect the functions inside. Okay, and you can have as many as long as possible. You can have that. Okay, I think maybe giving you another example to see. Let's say we have square root of x plus square root x. What is y prime? And then another one, let me just give you to think, and then maybe sometimes uh, I will solve for you. So another one is you have y equal to x plus x plus x plus x plus dot dot dot. Okay, so the second one here is, of course, I think it's more seems or it seems intimidating. So you have the square root of x plus square root of x plus square root of x plus, and then it's continue to infinite number of x. Okay, but I think if you check, I think some online website or maybe uh, any online lectures, I think that it's already been solved. But if you want uh, to challenge yourself, you can check this. What is the derivative of this one? Okay, I hope at the end of today's lecture you can solve this. Okay, but first let's just solve this one that are more I think reliable for you. Uh, Square root of x plus square root of x. Okay, just that. So what is the first derivative? So we can write here. We can write. Let's say the whole thing is the outside function. Let's say this is f. If you want to make it f, and the whole here, the whole inside is square root is g. So we will have, if this is f, let me write one more time here, then y prime is. Okay. And then we can start to work on f prime is 1, over 2 square root x plus squared x, right? And then maybe write a thing here, d dx of is x plus squared. Okay. So this will be, let's check. Okay, so this will be, we can say that this is, oh, why this is having square root, sorry. Okay, so this is 1 plus 1 over, okay. So we can write, if the questions didn't ask for a specific form, you can write in any form, like maybe in the exam, I just give you this question and you write until here is, or it's correct. Okay? Unless I give you maybe A, B, C, D, and the whole thing in A, B, C, D is different, and you need to do something with this. Okay. Okay, that's the chain rule. Uh, in another way, if you have this kind function here, like the beginning, this sine x, and you have the squared, you have the power set, right? You have 5 here, which means that this is in terms of definition, it's called the power rule combined with the chain rule. Okay, with the chain rule. Um, you will see in the calculus, especially if you have the textbook or maybe you see the chapters. There are a lot of words, terminology, and some subtitle like this subtitle, power rule combined with the chain rule. I think it is not really important if you are not really know the terms. Okay, as long as you understand the concept, that's okay. You maybe you forgot what it's called, but you know how to deal with it. That's okay. That's okay. I think in math or color, it's not too important to check all the, like for example, you need to really see all the title. I think for several sections, that's still okay if you don't remember all. Okay, like for example, this one, I think this is just what we have done before, right? We deal with the outside function, inside functions. We still get the same conclusions, right? Okay. Oh, I think we also we already deal with this, right? You have b dx, and then b with power of x. This is b x and b, right? Or maybe if you maybe not remember this, let me write from the beginning that let px that y is equal p with power of x, and then p with power of x is actually we can write as e with ln p and then x, right? Yeah. And then when you have this d dx p with power of x, we can set up our derivative of e. This is another way to look at. Okay. Previously, I stated using the limit definition of e, right? So this is uh, doing a little bit different, but it's still the same, still the same way. So this will be e ln p x, and then d dx of the ln itself. And this will be e and b, and then this is x. d dx of ln b x, this is just ln b. We derive with respect to x, right? And this is becomes the b with the power of x and ln b. Yeah, same thing. You can also think in using e as the exponential function. But I think that's all for the chain rule. Yeah, I think uh, the rest of the chain rule will be maybe practice and maybe exercise. Maybe I will give maybe just maybe 8 or 9 questions as exercise for you for the chain rule, okay, or maybe product rule, quotient rule. Okay. Oh, any questions before? Any questions? If there's no questions, I will continue to the next part. The next part is actually about we call the implicit differentiations. I'm not sure whether you get this in high school because I also forget. Oh, Rion. Okay. Which one? This one, right? What's your answer? Let me check. Uh, I think, yeah, there will be y inside. I think correct. I think. Okay, but let me check later. Okay, let me check later. Okay. 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 We will be back to these functions later, or maybe next Thursday. Okay. But let me just give you these implicit differentiations, because one way to solve the previous problem is, I believe, the easy way is to use the implicit differentiation. Okay. Oh, by the way, do you want to take a break or no? But I don't mind, like, if you are going to toilet or maybe buy drinks and then come back. It's fine. Maybe at any time you want it, that's fine, as long as you don't make noise. Okay. Okay. Let's just continue. Okay. Implicit differentiations. from what we have learned, we just learn so far. We learn uh, functions expressing only one variable. Like for example, y equal f of x, and inside this y is having x squared plus 2 plus 2x plus blah blah blah, right? Maybe sine x, and so on, right? That's what we have learned. However, however, some functions define implicitly. So what does it mean implicitly? Um, Implicitly by relation between x and y. Like the easy example is the circle. Now you have x squared and also y squared. And then you have the whole circle like this, right? If you want to define this as a function, this will be difficult, right? Because you have the vertical path, right? And you know that, oh, we cross this point here, point here. What do we do now, right? The other, or the idea is to look at y. Like for example, we can set y in terms of square root of 25 minus x squared, which is the whole thing above x-axis, or the negative part of it, right here, right? And there's another functions, like for example, the x cubed plus y cubed equal 6xy. This is called the volume of the card. Um, if I draw this, it will be looking like, yeah, more or less like that. Okay. Should be going a little bit down. Okay. And we can also think in terms of x cubed plus, let's say this is, if this is f of x, and then equal 6x f of x, right? Okay, now how to deal with this when we want to take some differentiations, like we take some derivative, okay? So this is how implicit differentiation takes part, okay? So implicit differentiation, let me write here. This is differentiating both sides with respect to x and solving the equation for dy dx. Okay. So what does it mean? So if we have x squared, we have x squared plus y squared equal 25. Okay. We can differentiate both sides. Or let me just write this and then take ddx. Mean left and right will be differentiated by ddx. Okay. Okay. ddx means you derive with respect to x. Okay. So x squared, yes, 2x. But what happens to y? Y squared. What happened to y? Okay. Here's why it's called implicit. Okay. So we are going to differentiate y similar to x. Similar to x. So we write, let me use different color, to y, but because it has x, so we need to, because it's y and it is d dx, we need to write another dy dx. And this equal, it's 0. Okay. So because y is function of x, like we mentioned earlier, then to solve, wait, there's here. Okay, yeah. Okay, so when we try to differentiate this, okay, because y is actually function of x, then we need to remember that there is a connection between y and x. When you derive with respect to d dx here, differentiate y, you treat like an x, but you need to add dy over dx. Okay, so that means we deal with the differentiation implicitly. So implicitly, we are differentiating and treating y as x, okay? And we deal with the dy dx. And then to solve this, we need to solve the dy dx. So we need to write here, dy dx then is negative 2x divided by 2y, or this is just negative x over y. So the first derivative of the circle equations, we can write negative x over y, the first derivative. Okay. So whenever you have a long equation and you see that there is y inside, and you know that y is actually the function of x, then you can treat them like an x and then put in dy over dx. Okay, any questions? Any questions? Yeah, this one? Okay. Okay, so if you want to check the first derivative of this circle, and you deal with this, you deal with this, the answer for the first derivative is dy over dx, right? So dy over dx, we need to find solution for dy dx. So we just put here and divide by 2y. Okay, so that's how you get this is negative x over y. So every time you are doing implicit differentiation, if the question is asking what is the first derivative, then this is not the answer. The first derivative is, remember, it's always dy over dx. Okay, okay, it's first derivative. Sometimes it's asking maybe second derivative, and you can do actually similarly. The idea is still the same. You're differentiating both sides respect to x, and then solving the equation for dy dx. Okay. 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 The other thing is, we know that this is implicit differentiation using directly differentiate this. But how about this, right? How about just regular um, regular derivative? Let's say we have the, or maybe we can let's go to the slides here. Um, let me check the questions. Okay. Okay. Find equations of tangent line to circle. Let's just the circle that we have already done. So at 0.34. We already done this. Uh, dy over dx is negative x over y, as we mentioned before. And we can also write this as negative 3 over 4. Or maybe we can write dy dx at 3, 4 is negative 3 over 4. And then we can have the equations, and you can have 3x plus 4y equal 25. I think it's not a problem. But what I want to check is, we can make this x squared plus y squared equal 25 as these terms. Okay. Now we want to check at 3, 4. So we have two equations, right? We have the positive and negative. But because it's 3 and 4, it's above x-axis, right? So you have 3, 4 is maybe around here, or maybe here. So we are using this upper circle. Okay, this is just to show you that you can also do this. Okay, so we are dealing with the y is equal 25 minus x squared, and we get y prime is, and then this is minus 2x. Cancel this. This will be negative x. Okay, and then lastly, dealing with x equal 3, this will result negative 3, 9, 16, 4. Okay, just to show you that you can also do this way. Okay, I think that's up to you which method you feel more reliable. I think for some parts, when you have like long equations and the equation has x and also y, I think you can go for implicit more. I think it's more easy to approach rather than you try to simplify the form and make it into y equal some variable x. Okay. Okay. Let me give you another idea, maybe examples, maybe example for the implicit one, and then the second derivative are implicit, and then maybe we can move to the other section. Okay, maybe we can have another example. Um, Find y prime if sine x plus y equal y squared cosine x. It seems a little bit complex, but I need to try whether you can see how to solve this. So this is combining chain rule, implicit differentiation, trigonometric, okay, and see how you can process this in your calculation. Let me give you some time to check. Okay. And let me see and check whether you get the idea. That's okay. That's okay. You try. Get the. Okay. Okay. Good. It's a little bit complex and I think a little bit long. Okay. You get this. Okay. Okay. Uh, check also. All right. We can start with sine. Okay. Sine x plus y. Um, we can differentiate sine easily. We get cosine. We can write cosine, or probably we can write the whole thing first. Let me write sine x plus y, and then y squared cosine x, and then we differentiate all the things from left to right. So this will be cosine x plus y, and then we need to differentiate. Let me write a step, one step one step. X plus y. Okay. And this will be, remember, we have y squared cosine x. So this is f, this is g. We need to have the product rule here, right? So we can write this as 2y cosine x, or maybe 2y dy dx, and then cosine x plus y squared negative sine x. Yeah, we at least we get this, right? And maybe solve this one first. So cosine x plus y. This is 1 plus dy dx. Okay. We can solve this cos x plus y plus cos x plus y dy dx. Is it too small or too small? Sorry. And minus y squared sine x. Oh, I think better if I'm just using this. Oh, I think better this way. Okay, better. All right, then we can group all together. Or maybe I'm just minus 2y cos x okay. Then dy dx is can write as this, or if you want to change the negative, you can also write in terms of plus. So multiply all with negative. This will be 2y cos x minus cos x plus y. Yeah, quite long and quite a little bit complex. Okay. So because we have we already have product rule, quotient rule, some basic derivatives, trigonometric, exponentials, um, chain rule, and then implicit. Sometimes the problems, maybe in your textbook or maybe in the exam, we will have some at least more than 2 or 3 combined together. At least two to set of differentiation rules that is together in one question. Like this one, it has first, we see that it's implicit because it has y, right? It has y, and it also has the product rule, and of course it has the chain rule. So it has three rules inside, and you need to one by one check getting all the process together. And I think this is because uh, it's quite long. Of course, if you are having this in your online quiz, I will not give you this kind of question in your the online quiz that has timer. It's too much. Okay. Uh, yeah. Don't forget to take the quiz, and also for the online students now who are joining online, don't forget to take the quiz. Okay. The last attempt is tomorrow before 9 a.m. or at least 8 a.m. is, I think, better. Okay, because 9 a.m. you will not be able to uh, join the quiz. Okay, so let's join the quiz if you haven't. Maybe try tonight or maybe tomorrow, really morning, early morning, maybe 7 or 8. Okay, yeah, the quiz. I'm not sure. It has sounds, right? Did you guys join the quiz? Have you joined? It has some music, right? No, okay. I haven't checked the music, but I just checked the settings. Actually, the quiz is the set of the quiz is having like a game. Uh, but I think for calculus, I turned that part off. So actually, if I set on for all the settings, it will have the bonus. So some question will have like a bonus. You will get some ability, like you will have like immunity. So when you have wrong answer, you get one chance to correct your answer. So it's like a game. But I turned that off for the first trial to see the platform is okay or not. Okay, but maybe later I will turn that on just to make it more enjoyable. Okay. And also I make it uh, for each question have a timer so that you can focus one by one, checking the answers. Okay, if I make like for example 30 minutes and I give you directly 15 questions, I'm not sure whether you are be able to because I'm not sure uh, you guys can do it in any way, right? Uh, so I'm limiting the time. Actually, you can look your notes, check your graph if you have the time. But because I shortened the time, so you can only focus on that question. But you still have like if you prepared notes or that's still okay. It's just a quiz. Okay, but I make like shorten time to make sure that you really understand the question. Okay. Okay. But we still have another quiz later. Um, maybe in maybe before we are going to have the midterm, we'll have another quiz. Maybe the physical quiz. Okay, physical quiz. Okay. I think we can continue. Uh, okay, we can continue to still implicit, but I think I will go. Okay. Okay. I will go directly examples and then I will make conclusion. So fine. This is y double prime. If okay, see if you get the idea or not, and then we can have some conclusions. course, if you are going to look for the second derivative, you need to look the first one, right? You need to look first derivative. Okay. So look for the first derivative. Okay, so if we have x with the power of 4 and y with the power of 4 equals 16, by doing implicit, okay, I think you get the result easily. It's not a complex function. And you will get that this is 4x cubed plus 4y cubed, and then dy dx equals 0. So you will get dy dx or dy prime is equal to negative x cubed over y cubed, right? I similar what with the previous one, x over y, but this is having cube. Okay. Now the questions is y double prime or the second derivative. So what you can do here, you can differentiate one more time of this negative x cubed over y cubed. Okay, how to differentiate this? It's a rational, right? It's a fraction. Then you need to use probability quotient rule. So we can take this. So y cubed and then squared. And maybe take the negative outside of this equation. Maybe here. So we have d dx of x cubed, or maybe let's just write directly. X cubed will be 3x squared, and then y cubed, and then minus x cubed, and then this will be 3y squared dy dx. Okay. Now, dy dx here, in this quotient rule, we can use from here, substitute, okay? And then the whole thing will be 3x squared y cubed. So this is 3y squared. Okay. And then this will be y with power 6. And then solve. Maybe directly write this as x squared y4 plus x6. Okay. Simplify. And then this will be y7. So you simplify this, simplify, and get this. And we can also, I think we can factor x squared. Okay. And then looking back, that x with the power of 4 plus y power of 4 is equal 16. So the whole thing here is equal 16. So we can write this will be negative 316 is 48 x squared divided by y with power of 7. Okay. Any questions? Any question from here? So basically, the idea of the second derivative for implicit differentiation, it's the same or similar idea. Uh, First, finding the first derivative. Okay, the first derivative you find, then derive it one more time. Derive it one more time, you get this. Okay, and then you get the whole quotient rule things here, and eventually you will get another y prime here, right? This is y prime. So you can substitute the previous one here, substitute the dy dx, substitute here, and you will get these equations. Eventually, when you try to simplify, you'll get that, oh, you can simplify this. Okay, and I think frequently this happens. Okay, so when you have this expression here, sometimes you need to simplify, especially if the answers need to have this answer. Like it has simplified in some terms, then you need to simplify. Okay, except if the question is just asking y double prime. I think if you just answer until this, still okay, still okay. But if the options are given, then you need to go to this following answer. Okay. Is there any question? No? I think I can go for a little bit just in introductions to the logarithm derivative of logarithm. And after that, we can have some feedback. Okay. So first is logarithmic first. Okay. Okay. Let's start with the by equal x. I can also write this in terms of log y, log the base and x, right? Okay. If we are going to have these equations to be differentiated, let's try to differentiate this with respect to x. Remember that when you have bx, you are having bx, ln b, right? Okay. So we are doing the same thing, but now it's y. Okay, it's with power of y. So this will be b with the power of y, and then ln b, of course, and then dy dx. And this, the other one is will be 1. So dy over dx will be 1 over b power of y ln b. Or we can write as 1 over x ln b. Okay, again, if we put b equal e as in our definitions, then our d dx of ln x, this will become 1 over x. And this is, I think, another important derivative. Okay. And also this is also to prove that ln e, because it's 1, then the ln use, because when b is e, ln e becomes 1. So it's practically useful in some calculations. If you see the graph, this is the ln and the derivative. You will notice that it has a unique property that the derivative is become this and this, right? But the log, the logarithm is just this. Okay? It's going down at two sides. It's going to have a negatively large infinity. Okay, I think the next part I will show you later in the Thursday class, but at least you get the idea that this log we can differentiate and then becomes 1 over x. Okay. Okay, now we are going to have some feedback times. So yeah, you can prepare pen and paper. Also, scanning the QR code. Wait for a moment. Okay, let's present. Okay, I think, okay. Okay. I think if it's difficult to scan, you can just go to the website and just put the code 404350. Okay, waiting for other students. All right, I'll wait maybe a little bit more. Okay, I think we can start. I hope the time is enough. If not, then we can reset. Okay. Yeah, 1 minute. Find an equations of the tangent line to the curve y equal to x sine x at the point pi over 2 and pi. I hope enough time. Get ready. Half minute. Okay, 3, 2, 1. Okay. Time's up. Oh, okay. Still okay, I think. Okay, is Kari here? No? Is Kari in this classroom? Oh, okay. Okay. Okay, get ready for the next one. Okay, 1, 2, 3. So sorry if this is, I think, too long, but I give you 1 minute 12 seconds, 20 seconds. I hope enough. I hope enough. Okay. Okay, 20 seconds. Okay, 10, 9, okay, 5, 4, 3, 2, 1. Okay. Okay. I will check later and should be correct answer. Okay. Yeah, you can write some suggestions, some feedback. Okay. I made mistake the previous question. Okay. Okay. Uh, right here. Oh. Oh yeah. Sorry, the question is too complicated. Okay. The answer for from the previous R prime is 120. Anyone get the answer? No, right? Okay. Yeah, sorry, that's I think too difficult. Sorry. Yeah. Sorry. Sorry, it's too fast. I'm just trying whether you can have time on the quiz make it very stressful. Okay. So sorry for that. Okay. Yeah, okay. If you don't have more feedback. Oh, okay. More question on quiz. Oh, okay. Oh, okay. Okay. All right. You got any question from the classroom? Okay. Okay. Sorry for the last question. I think that's too too difficult to calculate. Okay. Sorry. And I need to. I think adding more times for the last question. Okay. I think for the online students, if you don't have any more questions. Okay. Okay. I think. Okay. Okay. Yeah. I will give you maybe few minutes to check the screen and then make sure that you get the notes. Okay. Okay, exercise. I'm planning to give you exercise, okay? And then the key answer also. Okay, if there's no question from the classroom, I think we'll be finished. And yeah. Okay, so the class is ended. So for online students, you can also leave the Google Meet. Okay, thank you for coming. And if you have trouble to uh, joining the quiz, the first quiz, please let me know if you have any technical problems, because this is actually the first time I'm using the platform. Because I'm seeing the platform, I think it's quite good because I can write uh, function inside the question. So yeah, rather than just giving you the Google form and then it's just I think for me it's not too easy to be adjust. Okay. Okay, I hope the platform is okay with you. Okay. Okay. If there's no questions, then I will stop the recording. Okay. Okay. Goodbye.